Using the linear factorization theorem to find polynomials with given zeros. A vital implication of the fundamental theorem of algebra, as we stated above, is that a polynomial function of degree n will have n zeros in the set of complex numbers, if we allow for multiplicities. This means that we can factor the polynomial function into n factors. The linear factorization theorem tells us that a polynomial function will have the same number of factors as its degree, and that each factor will be in the form x minus c, where c is a complex number. Let f be a polynomial function with real coefficients, and suppose a plus bi, where b does not equal 0, is a 0 of f of x. Then by the factor theorem, x minus a plus bi is a factor of f of x. For f to have real coefficients, x minus a minus bi must also be a factor of f of x. This is true because any factor other than x minus a minus bi, when multiplied by a minus a plus bi, will leave imaginary components in the product. Only multiplication with conjugate pairs will eliminate the imaginary parts and the result in real coefficients. In other words, if a polynomial function f with real coefficients has a complex 0 a plus bi, then the complex conjugate a minus bi must also be a 0 of that function. This is called the complex conjugate theorem. The complex conjugate theorem states that according to the linear factorization theorem, a polynomial function will have the same number of factors as its degree, and each factor will be in the form x minus c, where c is a complex number. If the polynomial function f has real coefficients and a complex 0 in the form a plus bi, then the complex conjugate of the 0, a minus bi, is also a 0.